Okay, in this video we are just covering 4.5 part A as in your notes, starting on page 48. Derivatives of logarithmic functions. So the last couple sections we did derivative of exponential functions. Now we want to take the derivative of logarithmic functions. So it says start with your basic logarithmic equation. F of x equals log base a to the x. Okay, now remember, if we rewrite it as an exponential function, that's the same thing as a to the power of f of x equals x. So a logarithm allows us to write an equation in the form y equals or f of x equals, because it occurs when we have f of x or y in the exponent. Now, they're showing you that if we take the derivative of both sides of this equation, we get this as written, so we can solve it for the derivative of y, or the derivative of f of x. Okay, so we divide both sides by a to the f of x and natural log of a. So notice if we simplify that, we get a 1 over a to the f of x times natural log of a. Now, notice back at the beginning, a to the f of x is equal to x. So they substitute in x. So our final answer, if f of x equals log base a of x, then the derivative, following our laws that we've learned so far, is 1 over x times the natural log of a. Okay? All right, so we'll be applying this a whole bunch. Okay, so find the derivative of y equals log base 3 of x. So applying our law we just discovered, we would have 1 over x times natural log of the base. And that's it. There's nothing to simplify. Now, if our logarithm is base e, so the natural log, instead of log base 3, like in the previous example, we have ln, so a base of e. We would get 1 over x times natural log of e, which was 1 over x times 1. Natural log of e is 1, so it's simply 1 over x. Okay, so this next example asks us to find the derivative of y equals negative 13 natural log of x plus 3x squared minus 5. So again, the derivative of natural log of x is just 1 over x. So we would have 13 times 1 over x, or 13 over x. Derivative of 3x squared is just 6x. And derivative of negative 5 is 0. Find the derivative of y equals x squared times natural log of x. So we have the product rule. Okay. So we would take the first term times derivative of the second. Derivative of natural log of x is 1 over x, plus the second term times derivative of the first. Derivative of x squared is 2x. And if we simplify this, x squared times 1 over x is just x, and then we're going to write our 2x in front of the natural logarithm. Another example, s equals t squared times the natural log of absolute value of t. Okay, now we cannot take the logarithm of a negative number. Okay, so it was kind of assumed that this would be positive anyway. However, we can keep the absolute value in, kind of ignoring it as we find the derivative. So again, we have the first term times derivative of the second. So derivative of natural log of t, we'll keep the absolute value around it if we want. However, it will be positive. Plus derivative of the first, so 2t times the second term. So simplifying this, we would have t, so one of these t's cancel, plus 2t natural log of t. Again, our t must be positive anyway, so that allows us to simplify. Okay, v equals natural log of u divided by u cubed. So applying our quotient rule, we must take the denominator times derivative of the numerator minus the numerator times derivative of the denominator divided by denominator squared. So derivative, when we simplify the numerator, we have u cubed times 1 over u. So we get u squared. We're again going to write our 3u squared in front of the natural log. And in the denominator, when we have an exponent raised to another exponent, we multiply those. So we're going to multiply the 3 and the 2 to be a 6. Now there is one more thing we can do. We notice in the numerator that we have a u squared here and a u squared there as well. So we could factor that out. And we get u squared times 1 minus 3 natural log of u. And that would allow us to simplify with the denominator. So this u squared simplifies with the u to the 6th to become u to the 4th. So we have 1 minus 3 natural log of u over u to the 4th. Okay, next example. We have y equals natural log of x divided by 4x plus 7. So again, we're going to apply the quotient rule. So we have the denominator times the derivative of the numerator would be 1 over x minus numerator times derivative of the denominator is simply 4, all divided by denominator squared. So we can simplify this. We can distribute our 1 over x to each term here. We'll see if it helps. We have 4x times 1 over x is 4, plus 7 times 1 over x is 7 over x, minus 4 natural log of x. Again, we're just writing that 4 in front, over 4x plus 7 squared. Now, mostly we do this because we don't want this x, a fraction within a fraction. We want to ultimately get rid of that. So what we'll do next is multiply numerator and denominator by x. So when we distribute that x in the numerator, we're getting rid of that fraction there. So we end up with, as we distribute it, 4 times x, and then 7 over x times x would just be 7, and then multiply that last term by x, we'd have 4x natural log of x, and in the denominator, we're just going to write it out front and let it hang out. We're not going to multiply anything or distribute anything. We're just going to leave our answer like this. Okay. Y equals x cubed minus 1 divided by 2 natural log of x. So again, quotient rule. We take the denominator times derivative of the numerator. So derivative of x cubed would be 3x squared. Derivative of negative 1 is 0. Minus the numerator times derivative of the denominator. So we have 2 natural log of x. Derivative of natural log of x is 1 over x. So we get 2 over x divided by the denominator squared. Okay. Now we want to, again, do the same thing we did to the last problem. And in our second portion, we are going to distribute this 2 over x to each term. So, and we could also distribute that negative. You can do it in 1 step or 2 steps. I'm going to delete that. So we're going to do it in 1 step. So we have negative right here, don't forget that, x cubed times 2 over x would give us 2x squared. Right, so the exponent decreases by 1. And then we have 2 over x times negative 1, but we also have that negative there, so it becomes a positive 2 over x divided by our denominator squared. And like before, we don't want a fraction within a fraction, so we're going to multiply the entire numerator and denominator by x. So we would have 2x natural log of x times 3x squared. Oh, let me simplify that. Okay, so here we have 2. We can combine the 2 and the 3x squared, and then we also have the x multiplying. So we would have 6x squared times x would be 6x cubed natural log of x minus, multiplying the next term by x, we have minus 2x cubed plus 2 all divided by x times 2 natural log of x squared. Okay, now we could cancel a 2 from the numerator and denominator because we could take this, let's see. We could take this denominator and square the 2, right? So we would have 2 squared is 4, so we'd have 4x times the natural log of x squared. So in other words, we're distributing this squared thing to the 2, okay? And now we have an even number in the numerator and denominator. We're just going to divide everything by 2. Oh, I totally missed my, as you see my error, you probably saw it. In this first term, I totally left out my natural log of x for some reason. Okay, so go back and fix that. 3x cubed natural log of x minus 2x cubed plus 2 divided by 2x natural log of x squared. Again, you could probably leave the answer here and my math lab would accept it, but this is more simplified. Okay, so we have f of x equals 3x plus natural log of 3x. So when we find the derivative of our first term, 3x is just 3. Derivative of the second term, this is a little bit different. So when we take the natural log of 3x, the derivative, we have 1 over the term we're taking the derivative of, okay? So the entire 3x times the derivative of the inside function, so times 3. So the derivative of x equals 3 plus 1 over x. These 3's cancel. Okay, last example. Find the equation of the tangent line of the function f of x equals 3 plus 8 natural log of x at x equals 1. Now, the tangent line, remember our derivative is the slope of the tangent line. Okay, so the derivative is the slope, a little bit of review, of the tangent line. So if we find the derivative of this function, we will know the slope, and then we can use this fact to find the rest of the equation of the tangent line. So the derivative of this, f prime of x, is 8 over x, right? Derivative of 3 is 0. Derivative of 8 natural log of x is 8 over x. So if we want to know the slope at 1, we are looking for when x is equal to 1, we would just have 8. So in other words, our slope is 8. Okay, so to find the equation of in the line, we need a point. So if we're looking at x equals 1, we need to know the y value. What is the y value? What is y when x is 1? So we go back to the original function, plug in 1. Now, in case you didn't know, natural log of 1 is 0. Anything to the 0 power is equal to 1. So you can try it in your calculator as well, but natural log of 1 is 0. So f of 1 is 3. So that would mean we have the point 1, 3. X is 1, y is 3, and we have a slope. So if we use our point slope equation, y minus y1 equals m times x minus x1. We plug in our oh, y minus, I don't know why I have a 1, y minus y1. Our y1 is 3, our slope is 8, our x1 is 1. And then we can just simplify this, and we get y equals 8x minus 5.